Good evening and welcome to the seminar from traffic modeling to smart cities and digital democracies. Today we're going to have two presentations and we're going to start with the presentation of Adam Dada, Modeling and Prediction of Ride-Sharing Utilization Dynamics. Adam is 22 years old. He writes and comes from St. Gallen. Adam is second-year computer science student at ETH, who previously completed a Bachelor of Science in Business Management from King's College London. Adam has a keen interest in the intersection of technology and business, and he is fascinated with innovative solutions that improve today's world through technology. Adam, we want to see how this is going to happen, so welcome.
All right. Thanks, Professor Helbing, for this short introduction. And with that, I would like to start with my presentation on the topic of modeling and prediction of ride-sharing utilization dynamics. And that's a paper by Al-Chul et al., which is a collaboration between MIT Media Lab and Israel Institute for Technology. All right, let's begin. Does it work? Okay, sorry. So to start off, I would like to give you a brief summary and tell you what to expect over the next 20 minutes to 30 minutes. So the benefits of ride sharing have widely been demonstrated across recent years. However, there's been delaying factors that kind of hamper the widespread use of ride sharing. And that's exactly where the paper wants to focus on. And it picks one of these delaying factors, which is the volatility and predictability of the potential utilization of ride sharing at different times and in different places. And if we understand that better, then we can certainly help policymakers and urban planners to increase the ride sharing friendliness in cities. So the research questions that we would like to have answered is is ride-sharing utilization stable over time, or does it undergo significant changes? B, if ride-sharing utilization is dynamic, can it be correlated with some significant changes? Can it be correlated with some traceable features of traffic? And lastly, if ride-sharing utilization is indeed dynamic, can it be predicted ahead of time? And for that, the authors propose a data-driven framework to dynamically predict the potential ride-sharing utilization at different times and places. So the entire study is based on a data set of almost 50 million taxi rides that were collected in New York in January 2013. And as a first step in modeling the feasibility and efficiency of ride-sharing, we need to understand this data a bit better and to answer all these questions that I posed before. So our first step in the quest to see whether ride sharing is indeed stable or if it fluctuates is a distribution of rides per day of the week and per hour of the day. And on the right-hand side, you can see the probability density function of rides. And as you can see, the number of rides has a far from uniform time distribution. As you see in the middle, more rides are in the middle of the week, and on the weekends, there's lower rides by passengers. And secondly, the daily rides distribution peaks as expected in the morning hours and from 6 to 7, which are our rush hour hours. To further understand the data and analyze ride-sharing dynamics, the authors chose a network-centric approach to model the problem. So they took all the taxi ride records and constructed a rides network, T1, T2. And this rides network comprises a set of V nodes that represent equally sized squares, square regions of New York City. You can see them on the right, those little squares, and a set of edges such that each edge in this set corresponds to a connection between two regions U and V, if and only if there exists at least one ride from a region U to region V in a specific time frame. And if we aggregate this over all the writes, we get 830 nodes and almost 60,000 edges. And with this network approach, we can now look at some characteristics of the network that we assembled. Here, for example, we have the distribution of taxi rides on the origin destination routes. As you can see on the top right-hand corner, on the x-axis, we have the weight, which refers to the number of trips that took place through a certain edge, and the frequency on the y-axis, which is the number of edges that have a specific weight. As you can see, the distribution follows a power law distribution, which is heavily tailed. This implies that most of the edges induce a small number of writes, while a small number of edges induce an extremely high number of writes. Also, we can look at a distribution of the node degrees in our network that we constructed. A degree of a node, for those that are not familiar, is the number of possible destinations a passenger boarding a taxi on location V may choose to go to. So that will be all outgoing edges. On the top right-hand corner, we can interestingly see that while there are some nodes with a high degree, with a high frequency, the vast majority of nodes have a very low degree. Those with a high degree would probably be main train stations or large public facilities. And I would have to say that this observation is quite interesting and remarkable because it shows us that taxi users are actually quite predictable. But that's not exactly what the paper is focusing on, but they rather want to study the dynamics of those values, like the distribution of node degrees over time. Now, I'd like to familiarize you with a key component of this study, which is the ride-sharing utilization, which also goes as the shareability of rides. So ride-sharing utilization is expressed in terms of the number of rides that can be merged as a function of the maximum time delay that a passenger wants to incur to catch a ride. In this paper, in this analysis, we only merge pairs of rides that leave the same origin and go to the same destination. So basically the ones that have the same edge in our network. And we take into consideration the maximum time delay parameter. This has several advantages. For example, the approach is significantly less sensitive to events like traffic jams or accidents. And it is also easier to implement because the drivers don't really have to cooperate that much in picking up other people along the way. And it is obviously easier to optimize from a computational point of view because we don't have to really take the containing rights into consideration, which we would have to check whether they indeed pass through the origin and destination. So when we do that, when we merge all the rights, we would start off with the naive potential utilization. And I'll tell you why this is called naive. So first of all, on the right-hand side, we see that the results are quite encouraging. More than 70% of the rides can be shared when passengers accept a delay of up to 5 minutes. And the more maximum time delay minutes we take, the higher is the percentage of the merged rides. But as I said, this is a naive potential utilization because we assume that two rides that took place at the same time can always be merged, regardless of the number of passengers in a ride. But yeah, it could be that several rides that we could have merged more rides because because the rides are not always full. And on the other hand, sometimes the rides will be full and we could not have merged them at all. So we need to take these two effects into consideration when calculating the bound on the actual theoretical utilization. So as you can see in the distribution of the passengers, almost 50% of the trips only have one passenger, while almost 25% have about 2 passengers. So what the authors did here is they came up with 2 merging algorithms. On the one hand, we have the 2-phase greedy merging, and on the other side, the optimal merging. And these give us the bounds on the so-called actual theoretical utilization. The greedy merging, as the name says, it merges greedily and tries to maximize the number of merged rides. And this gives us an 81% utilization in comparison to the naive potential utilization. And on the other hand, the optimal merging, it gives us the upper bound, as we assume that whenever 2 rides are merged, the number of passengers they have receives the value that would result in the most efficient merging scheme possible. And as you can see, it would achieve 105% of the naive potential utilization approach. So this, in the formula, you can see how we would bound the naive approach. All right, so now I'd like to come to speak about the need for a more dynamic ride-sharing optimization. So up until now, the dominating approach focused on accurate approximation of the average state of the transportation system. So we would only optimize for the average state within a network. However, this really ignores the inherent volatility that we have been seeing now over the past couple of slides with their daily and weekly patterns. This would also limit the network's efficiency and potential utilization, which, as I said before, would prevent the widespread adoption of ride sharing in the years to come. So we really need to understand the dynamic nature of the network state if we want to make progress. And to do that, the authors propose to mitigate this problem by using a dynamic network, which is made up of a multitude of rides network snapshots that each represent a fixed length period of time. This approach is called sliding window, and it is especially useful for tracking changes in various dynamic network properties that are highly correlated with ride-sharing utilization. On the right-hand side, you can see one of those sub networks in a point in time. So this will be from the 144th hour to the 145th hour over January. So now we can do the similar thing that we've done before with calculating the ride-sharing utilization, but this time we average over all the sub-networks. So we do the calculation for each hourly network. And now we can notice that, in fact, we get a lower bound because we prevent passengers from being merged with rides outside the hourly network. And as you can see, the numbers are a bit lower. The percentages of merged rides, in fact, approximately 10% lower. And now, what the authors did in order to analyze the utilization into the future and also the current utilization and how it changes, they used 6 common network properties for each traffic network. And they used them to project each hourly collection of traffic data into a single coordinate. And I would like to now present you those 6 network properties that we use in our analysis. I quickly go through them, but I won't have time to go into detail, but you can read up on them if you want afterwards. So obviously we take the number of nodes as well of the edges. Number 3 would be the network density, which is the average degree of the network's nodes. We also take the average betweenness centrality, which gives us an estimation of the network's efficiency. At 5th place would be the average closeness centrality that yields an it yields an estimation of the compactness of the network. And lastly, we would use the average eigenvalue centrality. And this is a measure of influence of a node within a network. So with these 6 common properties of networks, the authors use linear regression and multiple linear regression to fit the potential utilization for the entire set of network properties. And now if you look on the right-hand side, you can see that the features have a high correlation with potential utilization for this hourly network. But most features have a low quality fit if you look, if you take them on a single basis, but if you combine them and mix them up, then we get a remarkably high correlation, as you can see in the gray dotted line on top. So this correlation can now also be used for predictive purposes. And in order to do so, we would first need to analyze the evolution of these various network properties of the hourly rights networks over time. And we start off with the evolution of the mean degrees of the rights network nodes. And here on the right-hand side, you can see the change from the monthly average of the mean degree of nodes as a function of time on the x-axis. This clearly shows that there's a dominant daily and hourly fluctuation pattern, and this reveals that there's a strong volatility in existence in the rights dynamics. A similar dynamics can be observed when we look at the evolution of the largest eigenvalue of the rights network over time. However, here, although we can see clearly patterns on top of patterns in the diagram, there is also some erratic spikes that are added to these patterns, but these spikes cannot really do not really have a regularity. So this implies again that in order to understand the dynamic in order to understand the utilization, we would have to really get to grips with the dynamic aspects of a network. And again, we can see a similar evolution, this time in the potential ride-sharing utilization over time. Again, there are clear changes in patterns in the potential utilization. This can be seen as sudden decreases in daily peaks, changes in the intra-weekly peaks, and these changes might even exceed the dominating daily pattern at some stages. And I guess at that point we can ask the question, can we find a statistical correlation between the current values of the rights network properties and future values of the potential ride-sharing utilization? And to answer this question, we first compared network properties at time t with potential utilization of at time t+1. So now we do a 1 hour prediction. And on the figure on the right-hand side gives us an example here, for example, gives us an example. On the x-axis are the mean node degrees of the network t+1. And on the y-axis is the change in the potential utilization of the rights between t+1 and t+2 compared to rights between t and t+1. So that's where the prediction component comes in. And it is easy to see on the right-hand side that there's a clear and strong negative correlation between the mean degree of the rights network and the potential change in utilization over a 1 hour period. We can do the same thing again, but this time for the correlation between the value of the largest eigenvalue of the rights network at time t and the change in the potential utilization between time t and t+2. So now we already have a 2 hour prediction. Again, in the figure on the right-hand side, you can see a clear, strong negative correlation that is easily visible. Just to give you an example, when, for example, the largest eigenvalue of the rides network is smaller than 0.012, the potential ride-sharing utilization was guaranteed to significantly increase in the coming 2 hours. The same goes for the largest eigenvalue of 0.014, which on the other hand indicates a significant decrease in the ride-sharing potential within the next 2 hours. And the previous two predictions, so the 1 hour prediction, the 2 hour prediction, can be validated by another set of data. So the two predictions from before were based on the analysis of the first 3 weeks of January 2013, but now we do the same for the last weeks of January. And as you can see from the figures below, we roughly get a similar distribution and effect. All right, so with the predictive power that we've seen now over the last couple of slides of this dynamic network, the authors constructed a multiple linear regression model that would fit all of these 6 properties. So they've created 18 models for 2 values of each distance tolerance. That would be 400 meters and 800 meters that denote the pickup and drop-off distance that still allow rides to be merged, and 3 values of time tolerance, 30 seconds, 2 minutes, and 5 minutes, which, as we've seen before, denotes the time passengers will be willing to wait in order to merge the rides. And lastly, 3 values of prediction horizons. Firstly, no prediction, then 1 hour predictions and 2 hour predictions. Yeah, all of these models are in the supplementary figures of the paper, but I picked one of those out, and on the right-hand side, you can see those. So I picked the example of a distance tolerance of 400 meters and a wait time tolerance of 30 seconds. And the topmost diagram would be the non-prediction, then will come the prediction of 1 hour, and then the 2 hour prediction. And as you can see, the accuracy of the model decreases with the increase in the prediction horizon. So all the blue dots are the adjusted data, while the red line is the fit. And as you can see, the more we do out, more the prediction horizon is, the widespread the kind of the blue data gets. And this shows us that with the increase in the time horizon, the model gets less accurate. All right. So lastly, I would sum up and give you a conclusion on what you've seen. So as I've said before in the beginning, the maturity of ride-sharing infrastructure is mainly measured by the availability of vehicles. And also, as said in the introduction, there are many factors that constrain ride-sharing, ride-sharing and their widespread adoption. And among others, the ability to offer a high utilization is really important here. And as I've said, a high utilization is the ability to merge similar rides with a given time delay for passengers. Up until now, the conventional approach has been a static environment and an optimization for the average case. But the last couple of slides and this paper in general shows that there's a dynamic nature to the ride-sharing system. We were interested in whether the ride-sharing utilization is stable over time and undergoes significant and rapid changes often. And that's where the authors came in and proposed a network-centric approach by using a sliding window approach, where we modeled the dynamics of ride-sharing utilization in respect to various network properties over time. and the results are pretty clear and demonstrate that there are significant volatility of ride-sharing utilization over time. And the results suggest that the approach that was proposed by the authors can indeed model and forecast the potential utilization of ride-sharing. Therefore, as a conclusion, I'd say that any policy, design, or plan that selects the static over this dynamic paradigm that was brought forward by the authors, that would undoubtedly be either highly inefficient or provides insufficient resources. And yeah, with that, I'd like to finish my presentation and would like to thank you for your attention and take your questions now. Thanks.
All right, thank you very much. We're ready for comments and questions. So this is student time.
Yeah, hi. Thanks for your presentation. Yeah, I have a question actually, and I guess it's a pretty basic one, but it's always the first thing that I think about when I see any kind of like regression or modeling thing pop up in a paper. And right, they use linear regression, you said. Did they ever try anything else? Right, I think that's like the most kind of obvious thing to do then, to see if it improves or not, if it somehow increases their predictive performance, or do they just say linear regression works and we're done?
So yeah, and what they've done, the authors in the paper, is mainly they used linear regression as well as the multiple linear regression to fit these network properties that I've shown you before, the 6 common network properties. Yeah. But actually, no, it's a good question from you. They did not go into detail of how they maybe, if you'd like, have a second approach to kind of back the results up that they've postulated in their research, but they haven't done so. The only thing that they did is they ran, I think, 18 models it was, with linear regressions, and they've listed them all in their supplementary figures, but they haven't really went into detail in another approach besides linear regression.
Sure, thanks.
I guess to me, my reaction to your question is kind of, it makes, I'm not surprised because I guess it's interpretable, and if it works fine, then why do something like the simpler model is a better model, simpler interpretable model if it works, best model.
I agree. Yeah.
But and I mean, the main
it would be sorry.
Go ahead.
I definitely agree with what you're saying, but I think it's always nice to have a comparison.
Yeah. But I guess we also have to take into consideration what the aim of the paper, the main aim of the paper was, and the main aim is just to show that ride-sharing systems do not follow a stable trajectory over time, but that they are inherently fluctuating and unstable over time. And so I guess the predictive effect of this model, it kind of goes into the second, it's kind of secondary. But first, I guess we have to just acknowledge the fact that ride sharing is indeed highly volatile, and we have to take into consideration those fluctuations in utilization. So I guess it makes sense that it not go into that much more detail of the predictive force of this model. I guess they also have a couple of other papers on similar fields. Maybe they went into detail on prediction in another paper.
All right. Now this is time for further questions or comments. Hello. Let me make a very simple question to everyone. So, who has ever participated in a ride share? Just to wake you up, you know.
I think the Uber, what is it, Uber X, or what's not the ride sharing one? Uber. I've used a number of times, And the one that we talked about, there's a ride sharing service in Berlin that I talked about in one of the first classes that is very popular, where you, but it's publicly run. Anyway, yeah. So the answer is
the barrel chronic, you mean?
Yeah, exactly.
I'm not even sure it still exists. I think Corona got them into trouble.
Yeah, Corona probably canceled all that business. Ride sharing in Corona dead.
Anyway, I'd like people to raise hands. You know, who's been sharing rides? Just to get you activated a bit. All right, some more people, maybe. I just want to see whether there's some hope for planet Earth. Yeah. More ride shares. I cannot raise my hand because I'm session share, but I've done it. Okay, this looks more hopeful, but there's still potential I can see. Now, given that some people have been activated now, are there further questions or comments? It doesn't have to be directed to the talk. I mean, maybe you want to reflect on the potential and limitations of ride shares altogether, you know, independently of the modeling of that paper.
I would have one more comment, actually, if no one else has anything that they want to say. And it's about the conclusion of the paper, I guess. And I don't know if I'm missing something, but to me, it seems quite obvious, right? That like the I don't know, demand or utilization or whatever of these services isn't always static, right? That there's a dynamic, like during a day, that you have some rush hour and some kind of hours when it's not as busy, as well as over a given week, right? Especially if you just do the kind of binary classification of weekend and weekday. And I guess it's nice to see that yeah, you can really, like, you know, thoroughly statistically show this and prove this. But I'm not completely, like, you know, blown away by the result that this is how this behaves. But I think it's interesting. Yeah. Still.
I guess that's a good point, because I was stunned as well that this wasn't that obvious before. When I read that the conventional approach up to date was kind of optimizing for the average. So they took the long-term average of rides and tried to optimize for that and base their decisions in whether to maybe build certain infrastructure. So on those long-term static data sets, if you'd like. So it seems that apart from maybe like innovative startups like Uber or Lyft and those sorts, the rest doesn't really go into much analysis of fluctuations in ride-sharing systems, or maybe, let's say, public transportation in general doesn't really make use of the volatility of the people or the riders. So maybe that was a call from the authors to maybe also on a governmental level to use more the analysis of this dynamic nature of ride-sharing systems to improve and potentially save money in the long term, because then you would not just aggregate for the average and miss out on a lot of fluctuation and cost saving, but then you would actually make sure that you kind of optimize for the fluctuations, daily patterns and weekly patterns.
Yeah. But like, wouldn't you think, I mean, this is just a general thought. Wouldn't you think that at least people that are somehow involved in public transport, like if you think of like this thing that they're doing in Berlin where they have a ride sharing that's kind of supported by the public transport authority, that they would kind of know this? Because if you just look at how, let's say, commuter trains work, right? Like they are very obviously somehow connected to peak hours, like during the morning and evening hours, they run at a higher frequency and maybe have higher capacity trains or something like that. So yeah, No, it's just more along the
Yeah,
lines of this should somehow be obvious, at least to me, but maybe it's oversimplified.
Yeah, I definitely understand what you mean. Maybe it was also in reference to, as they said, or as I mentioned on the first slides. Let me see. So the widespread adoption of ride sharing is kind of deterred because of this unpredictability of potential utilization. So maybe you would be in a place somewhere and you wouldn't really get rides, although some people would need them. Maybe they wanted to kind of go into detail of that, because if you just kind of optimize for the average case, the many people along the way which kind of scatter across the city are left behind. Maybe it's that, but I'm not too sure. Why this hasn't been that obvious up until now. Maybe it's also just because we are living in kind of in the reality of Uber and Lyft and that kind, so it's kind of obvious for us. I'm not too sure about that. We could investigate on that.
All right, any more questions or comments? No, if this is not the case, then I'd like to thank Adam for the presentation. We're moving on to the second presentation of today, which is going to be by David Hofer. And he's going to talk about algorithmic governance in smart cities, the conundrum and the potential pervasive computing solutions. David is currently doing his bachelor in computer science at ETH. In the meantime, between Gymnasium and ETH, David did his military service in the Center for Electronic Operations and then worked temporarily at a consulting firm in Zurich. He is interested in this seminary course. It addresses many interesting challenges and developments of our modern, complex, and connected society. And we are very much looking forward to this presentation on algorithmic governance in smart cities.
Okay, thank you very much for the introduction. So yes, my presentation will be about this paper, Algorithmic Governance in Smart Cities, the Conundrum and Potential Pervasive Computing Solutions. I'm afraid this paper is much less mathematic and technical than the ones we have seen. Yes, the authors aim to have a look at this problem and these developments that we can see in many cities today. Specifically now with the rise of big data, AI technologies, and so on. So the trend in today's society is more towards smartness everywhere possible. The businesses want to provide convenience for the user, for the end user. Essentially, we aim to make our society, our urban society, smarter, relieve us from simple, dull, repetitive tasks, and now even more and more from complex ones. And this is enabled by algorithms combined with tons of pervasive computing and data gathering everywhere to feed those algorithms. In other words, we have computation in every imaginable object and infrastructure, or at least that is the trend currently going on. And smart cities can take this to a whole new level. However, delegating too many decisions, too many responsibilities to the environment, to a algorithmic government can possibly lead to the opposite of the intended effects. We may become less attentive, lose control. And so there are many questions about how our data that is gathered is used, who it belongs to, who it controls, etc. And this paper discusses exactly these problems that could arise and aims to analyze the effect they bring at an individual and societal level. and yes, eventually aims to identify some key directions to attack those problems. So this rather short overview over the topics. First, we will have a look at smart cities and algorithmic governance in general, the state today, what already exists. And then the main points of this paper are the possible perils and dangers that come with algorithmic governance. It is explicitly mentioned that this paper is not about painting a dystopian view of the future, but instead analyzing what these dangers can be and how we can address them. Then the authors propose 5 approaches how to deal with these perils, and in the end come to a short conclusion. So many cities today start to incorporate certain aspects of a smart city. We have in Barcelona, for example, the City OS, which is a kind of network that connects different services, sensory infrastructure all over the city. And then we have Copenhagen, where the city worked with Google and installed monitors to create an air quality map and reduce air pollution. In Dubai, we have hotspots. I think these are around 5,000 hotspots around the city where people have access to government services and applications over the phone. In Madrid, there is computerized management of infrastructure, garbage control, recycling, and public spaces. And of course, there are many more of these cities that begin to develop into smart cities. And the authors of this paper expect that soon urban environments will be able to self-regulate most of its processes in autonomy and guide and support our everyday activities. And this is where the term algorithmic governance comes in. So as described in the paper, it concerns empowering software to take decisions and autonomously regulate some aspects of our everyday human activities or some aspects of society according to some algorithmically defined policies. So basically, these are decision-making algorithms that can take over control of some aspects of everyday life, even in law applications, in government, and so on. And the authors believe that living in such a smart environment will make ourselves smarter by increasing our overall levels of awareness of the ongoing urban activities, by increasing efficiency and participation in these environments. So we already have examples of this kind of algorithmic governance in many aspects of our lives today. So for example, Google search really dictates what information we see, because when you Google something, and this is the first main source of information for many people today, is that they Google, and so the PageRank algorithm that decides which results get put on which page effectively has a large influence, because nobody goes beyond page 1 in the Google search results. Facebook or Twitter newsfeed algorithms decide what relevant posts to show us, especially because for many young people there is this is the primary source of news, and it implies that they fully, or to a large part, delegated that this part of their lives to these companies, the part of searching and filtering information. And then moving on to the societal sphere, more than 80% of the trades at the stock market are currently being made by algorithms and not human traders. So therefore, affecting oscillation of markets and prices, and public transport and traffic light controls are prime examples that we have seen in this very lecture, in this course. Then there's, for example, airline pricing that is heavily based on algorithms. And if we now combine such algorithms with rising IoT and pervasive computing technologies, we get smart environments, smart cities. Pervasive computing, for those of you who don't know this expression, is embedding computational capability into everyday objects to make them communicate and perform certain tasks, often in a way that minimizes the end user's need to interact with the computer as a technical device. So it makes the technology more accessible. So this doesn't have to collect data, but in our current society, this is normally the case. And thus enforces the trend of collecting large amounts of data and make decisions based on it. Soon the paper states these, or this will make it possible that smart environments are able to sense at incredible levels of detail every single event happening in every corner of the city, and to trigger flexible actions to affect the state of things via a variety of infrastructure, actuators, robots, autonomous vehicles. So states the paper. And yes, this of course makes sense, since a large population and need for consumption and production needs good organization in urban environments. So the authors believe that the entire management of a city controlled by algorithms and autonomous engines will be possible in the more or less near future. This can include waste collection, traffic control, infrastructure maintenance, production, administrative processes, and so on. So these are all tasks that could be imagined as regulated and controlled without human interference. The goal, or maybe more the dream, is that it will make it possible to fulfill the highest level of this Maslow pyramid in his hierarchy of needs. Maybe you have seen this already. This is this hierarchy that ranks different personal needs on different levels. So we have on the bottom the physiological needs that include food, water, warmth, rest. Then we have safety needs. We have belongingness. This is in the section of psychological needs, esteem needs, and then on the top there is self-actualization. And here the goal is, of course, or the idea is, of course, that the smart environment can provide the fundamental, or the fundamental basic needs for us, and the population can focus on the higher levels of this hierarchy. And yeah, well, one of the key features of smart cities is that they collect data to improve the existing processes. However, it is not defined how this improvement of these processes looks like, because of course there is no formal definition of what the goal function for such a smart city is. This depends on the society or institutions controlling this. This might be environment friendliness. This might be maximum efficiency and production. This might be maximum profits for the controlling institution. So what exactly this improving the processes means is not well defined. And this leads us to the perils of the algorithmic governance. If we increasingly delegate the governance of our activities and decisions, and in the end the governance of the whole city, to algorithms, it could also have negative effects, as many can imagine, and as the authors state. Rather than taking advantage of the augmented capabilities of perception and participation, we could collectively end up giving up our decision making and critical thinking, losing attention, awareness of outside processes that regard the environment or social processes, and many others. descriptively said, rely too much on the system of algorithms to spoon feed us everything we need for our lives and lose control. Many of these problems arise mostly from the notion of algorithms as black boxes, where there is little understanding in the general society, in the general population, of how they work on the inside. And although we get apparently smarter as a society, our actions will be less conscious since they're dictated by an algorithm and not thought of by ourselves independently. And even if algorithms are developed for the sake of serving citizens with laws and regulations, transparency, there are still inherent problems that the authors identify. So first of all, this may be obvious but still important point that decisions may be biased and have inaccurate information, since everyone who has worked with statistics or machine learning knows this problem that these biases may be intentional or unintentional bias in data. There may be incomplete information, and since in a autonomous regulated smart city, this would be what these algorithms are relying on, then this is of course a key component and a key weakness if not addressed correctly. And yeah, there are many examples of how what could be the effects of this. So there was the example of face detection software not doing well for people with dark skin, or there are also, one can imagine situations where even if in doubt of the decision of the algorithm, so even if tempted to doubt the algorithm, the profitability to follow the algorithm's decision can still be higher than to not do so, even if that is not necessarily a good decision. For example, if an algorithm is applied in court for court decisions where a judge gets the decision of the algorithm for a specific court case, and let's say in a criminal case, then this judge might not want to go against the algorithm's decision for guiltiness, because the judge himself would then be responsible for a second offense in case that would happen. So it would be safer to just take the decision of the algorithm and therefore have a reliable backing, so to say. So then there is the risk of intentional misuse. Misuse of the algorithm by individuals or organizations, which is maybe the more dystopian view, because there is the issue of who is devoted to manage the algorithm and how everyone else can trust these people. For example, there will probably be developers who develop these algorithms, but they might be influenced by the government if this government chooses to do so. And there is also the possibility for the developers themselves to develop the algorithmic technology in a way that could be intentionally misused and towards the government, for example, hiding behind a veil of sophistication. So this raises the question how algorithmic government models for smart cities should look like to prevent or mitigate voluntary or unintended abuses. Who makes the rules? Who decides on the algorithm? Who decides on parameters? How does an objective function for the government model even look like? So there are many questions that would have to be defined in policy decisions, and there is definitely a big potential risk there. Exactly. So the third issue they recognize is that politicians and decision makers may end up having a little clue on the actual working of the algorithm, and thus lose power. So this notion of algorithmicity, as opposed to democracy, when the power lies within the algorithm rather than with the people, this may appear to be already the case in some parts. For example, visa decisions are already now based on many algorithmic calculations. So yeah, we still are in the danger of giving power to the algorithms and people developing them without really understanding what lies underneath it. So to prevent that, it is necessary for citizens, politics, and decision makers to become able to understand and harness the complexity of algorithms and their configuration. And then, of course, there's many other problems and questions: personal data, privacy, who owns what data. And although this is not the main focus of this paper, there is this interesting quote that I found, that it is this quasi-expropriating view that makes the term data ownership so dangerous to many. We built the device, control the interface, so we own the data. Now, whoever built James Joyce's typewriter does not have the copyright to Ulysses, but that's exactly what car manufacturers demand when they secure their access and rights to mobility data. So, of course, also this quote does not tell the whole story, but this is, even though it is not the main focus of this paper, this is definitely an important point whenever large amounts of data, personal data, are gathered. So how to deal with these problems? And the authors propose 5 solutions that I will in the following discuss. And yes, we will directly go into them. The first one, data access control. So like I said, large data collection raises privacy and algorithmic concerns. And data collection in a smart city especially would be of this enormous amount that it would allow for a complete construction of digital biography, daily patterns, opinions, lifestyle of an individual. And of course, the entity, the institution in possession of such detailed information would have power in some sense over the individual, over said individual, resulting in potential misuse by government or organizations. And the authors identify the need for configurable privacy-preserving tools that afford users fine-grained control over how their personal data or personal information is used. And so the idea is to create digital tools that give a single individual access and control to his own data, so he can fine-tune the usage of his data in the algorithms. This is like, for example, now we don't really have a choice. If you use Google services, you accept their data regulations or not, but you cannot really fine-tune how this data of yours is used. And so this would be the idea here. And the users could also see how their data is used and how this data affects the algorithms. So this would also lead potentially to more transparent algorithms and data usage. The second idea the authors had is algorithmic guardians. The idea here is that even when seeing what data is used and how it is used, so the user that is, this might not be transparent or comprehensible to the user. So also it would be hard for the user to detect which personalizations exactly of his data would benefit himself, or what the effects of such a personalization are. There often is an interest gap between the individual and the party that paid for the algorithm. This conflict of interest might, of course, change with policy decisions. But the authors envision more advanced versions, more evolved versions of current personal assistants, like, for example, Siri, that will be able to aid us in algorithmic or protect us from algorithmic manipulation. And, for example, prevent us from being stuck in behavioral loops or echo chambers. So an echo chamber, this is the situation where beliefs of an individual or group of individuals are amplified and reinforced by repetition and communication inside a closed system. And this means the already held views are confirmed by the environment. For example, if an individual in this red network on the left gives out some signal, it would most probably receive the same signals back. So if you only follow people on Twitter that have exactly the same opinions and views as you, then this is also the only thing that you will see that the algorithm will show you, and therefore reinforcing your view of the world. So the idea is that these personal AI assistant helps in controlling the data flow and decide what digital trails to access and who can access your digital trails. Yeah, so to control your data and understand what's happening in the algorithmic world. The next solution approach is democracy through gray box code for algorithmy. The basic idea here is that it would, of course, be of benefit if the algorithm were public, but for people to actually be able to understand them, and with people, of course, not a small minority, but the large majority of the population, because if these algorithms decide on our everyday lives, then the people should be able to at least read them and try to understand them, like it is now today with our laws. Of course, there are people who studied law to understand the laws that we have, but still everybody can look at the current laws that we have and understand them. So these three incentives are better programming languages. They propose options for verification of programs, and since they predict that the future of our society will be more based on distributed and mobile computing with Internet of Things, this would mean there is a need for powerful languages that can support complex distributed code in a clean way that will still be understandable. And then inspectability of code means that these algorithms should function as kind of gray box systems that citizens can read and also influence along various levels of participation in democratic processes. So that the exact how to say, like we have our current laws today where people can affect those in democratic processes, that the base of the algorithm could be influenced on various levels. And then the third point is uses computing literacy, which is basically the point that computing and computer science should be taught in schools, so that people who grow up in this world with these given circumstances can also be able to navigate in it. Yeah, the general population should be able to understand algorithms, or at least be able to read them, and the algorithms themselves should be designed in a way that makes them understandable. The next point is the humans in the loop and the wisdom of many. given or yeah, the idea is to give people the ability for sharing and providing feedback regarding the system in kind of a forum, to give access to sensors and pervasive computing technology that also provides data for the algorithm so the people themselves can monitor the environment and detect problems with the smart city. And when dealing with ethical choices, then there should be the option or the need to involve humans in the decision. So in a case maybe where there is no time for first asking the decision of a human supervisor, there one can imagine that some algorithmic decisions are pre-made by a human in advance, so that the human accountability is retained, and then automatically this human decision is adapted to the situation, but still that a human is involved. And then of course, if it all fails, then there should be the option to pull the plug. Descriptively said that when there are systematic fails, there needs to be a way to regain control of the infrastructure, and it needs to be obvious for the controlling institution or instance how to do that, and the continuation of functionality must be guaranteed afterwards, which can lead to some tricky situation if you imagine self-driving cars, where yeah, this is definitely a valid point. And then of course there's a different possible form of wisdom of crowds, which would be the wisdom of crowds of algorithms. So the authors proposed that instead of one algorithm, there could be a number of independent algorithms that are devoted to the same concern, to the same process. Yes, but basically humans should supervise ethical decisions and should be able to influence the process, and the algorithms signal errors, and if necessary, pull the plug. And the last point is from context awareness to context control awareness. Pervasive technologies allow algorithms to make decisions based on the context they are currently in. So this is context awarenessness. And a possibility would be to transform from this to context control awareness. And here the point is that algorithms that can override control for a specific problem, for a specific process, are not given full access for adapting the devices under their influence, but are instead given shared access control, with a network of socially connected agents or decision makers. So these can be other humans, other algorithms, devices, etc. And then with humans and other agents as co-decision makers, this would lead to shared governance and allow the pervasive computing systems to be more considerate, in quotes, as they are not only aware of their own context, but also of how they influence and control, how their influence and control can bring unintended consequences to others. Exactly. So to summarize again, these are the 5 approaches: data access control, algorithmic guardians, democracy through gray box code for algocracy, and humans in the loop, and this context control awareness. And this would lead me to the conclusion of the paper, which is that the obvious advantage of the increasing availability of pervasive computing infrastructures is that they will make our lives much easier. However, this evolution also carries on potential risks for individuals and for society as a whole. And by blindly accepting the deployment of algorithms that run our society, we become dumber, as they say, society, or even lose control. And yes, dealing with these issues will require deploying a system of societal apparatuses in order to protect the individual citizen against the running code and or against the potentially malicious usage by individuals of the data that is collected and produced by the code. And there definitely are ethical considerations that must be central to the new algorithms that will be created in the future. So this was the paper, and I want to thank you for your attention. And then later on, we will go on to the discussion where I can maybe remark some of my own points regarding this, and then you can of course join in on the discussion about these solutions and the paper in general. Thank you very much.
Okay, thank you very much, David. Now it's time again to discuss the paper. Student time. Any questions or comments?
I have one question. You said, like rather in the beginning of your presentation, that one of the problems of like having algorithms deciding things is that they are like black boxes, so you don't know. So there might be bias depending on the data. But what I was wondering is that in the end, like every human decision maker or any human also has some kind of bias. Don't you think it would be easier to measure the bias in an algorithm than, for example, in a judge or in a human decision maker?
I think, yeah. Also, of course, this is the hopeful point of view. I think this is definitely maybe more more accessible and easier to measure the bias in an algorithm. I think the reason here, or the point why this seems dangerous, is maybe some kind of misconception that we seem to think that we have full control over these algorithms, while we don't even have that now, as you said, because in some way, of course, people are also black boxes that where we can't fully understand the biases that are inherent to them.
But the typical range of a normal person is limited, right? That means the damage a person can do is typically quite limited.
Exactly, yeah. This is...
An AI could have a citywide impact or even a nationwide impact. And from that point of view, you know, if something goes wrong, that could be much worse.
Yeah, exactly. This is a good point. Of course, there the question is also how is this control structure or hierarchy built up? So who controls what instance, and what instance can have a say in the decisions of these other instances?
I would be interested to know, how did you come across this paper and why did you choose it?
So the interesting point, or what I was originally looking for, was something focusing more on the smart city and digital democracy aspect of things, because that was what I found really interesting. So I was first searching for papers in the area of here a small part was also the wisdom of many, or how for example social networks can affect the popular opinion in a specific network, and then came across this idea of algorithmic governance, and with that I came to that paper. And because this fitted in the smart city context, yeah, it was a good fit. Yeah, I have some concerns or things about this paper I think are not optimal, which
For
I might.
example, I already wanted to ask you actually.
Yeah.
Do
So,
you feel happy? Do you feel safe now after this paper? Do you think the problems have been sorted out, or do you feel this is very preliminary and actually most of the work still has to be done?
So I definitely think, and this is also my first point about this paper, it's, of course, it addresses the problems, but there is not really work being done in this sense. So what I think is the upside is, and also the point of view that the author has had is, this is not about, like I said, pointing a dystopian picture, because there will hopefully still be an active society, laws, a functioning government that will still be in control, and the ideas of giving people the option to adapt to the new technologies and new environments that will be coming. But yeah, sorry. Do you?
Okay. Do you feel you know whom to talk to if there is an issue?
No, this is of course not the case, I think.
Yeah, we don't have a clue, who are the people who are supposed to be in control, right? So
this is true, yeah.
Yeah, that's an issue, right?
Mm.
I mean, do you think, for example, Zurich is one of the smart cities and we just don't know it? Or do you think it's going to happen someday in the future? Or what?
I think there is, in general, a large gap between, let's say, people who are familiar with these ideas, and so there are, for example, smart city indexes where I don't think Zurich is one of the furthest. So what do I want to say? I think, of course, our society in general is spread out quite widely. So there are certain countries, societies, cities where this will not be of relevance now in the smart city context for many years now, and other cities already started implementing part of this. So I think one of the problems is that our society is not that homogeneous to make this development in one go, so to say.
So if somebody has a question or comment, just raise the hand, okay? Otherwise, I'll just go forward myself.
I got a question, maybe a personal question, but do you think there's a ceiling on the level of smartness that a city can reach in relation to what level of smart services that humans would allow? Because, I mean, Western countries like the US or even European countries consider privacy and freedom really highly. But if they look at, for example, China, where they can see how smart face recognition is used against the people, would they maybe kind of not allow all of the smart technologies to happen in their city? What do you think?
Yeah,
maybe gives a ceiling.
Do you mean because we sort of deny ourselves access to certain technologies out of moral and ethical considerations, that we give ourselves a ceiling? Or
I mean more from the point of view that I guess there's some technologies that where if you give your privacy, kind of if you lay open all your books, it can help you, but you would have to kind of make everything public.
Yeah.
And I guess some people, especially in Western countries where they value freedom and privacy really highly, they wouldn't let technologies kind of invade their environment, although there could have been some use of the technologies.
Yeah, okay. I think this is also a question I ask myself, but I think there is right now not a satisfying answer to this question, because I think this depends heavily on how our society as a whole develops, in the sense that right now I think there are many data activists that that really fight for these issues, but there's also a large part of the population that I would say doesn't really care much about data privacy. So I think if in 10 years still 60-70% of the population don't really care if a company, a private company or the government knows when they were, what they did, with whom, and so on, I think then we kind of take this question away from ourselves, because if the large majority doesn't care about issues of privacy, then this will not be of this big of a concern. And as to the ceiling, I also don't know. This is kind of this question of emergence. How intelligent can such a complex system become? Yeah, which I'm not sure, to be honest.
Okay. I guess my follow-up question on that, I guess you touched upon that a bit. For example, in Western countries, do you think it should be private companies or more of the government that kind of takes the initiative on smart technologies? What would the people rather have?
I think what would have to be employed is of course some kind of regulatory body that would, I think, in the best case be kind of a combination of maybe government institutions and private companies leading in these sectors, because yeah, I think right now as it is, we can't just like tell Google and Apple and so on to give all their market influence and their power to the company to the government. And so I think there would be, I mean, in the optimal case, some independent council or something, but since this is really an utopian view that this is really independent, I think the best would be to have a assembled council between government and maybe institutions and companies. Yeah.
Okay. Clement?
Yeah, I was particularly, I think of the 5 different things that you mentioned. The one that I think is maybe most, or that I found the most interesting that I've thought of previously was the data access one. And I'm interested to kind of generally pose the question, what would it look like practically to give people access to the data that they generate online? And I was thinking about it like, could you have a law that says that for any company above a certain size, either in revenue or traffic or something, has to have an API that allows users on the website to view their data, the data that they generate there in real time, and to view, say, who's accessing it, what it's being used for, etc. Like, is this type of regulation something that might work? Does anybody have any other idea? Do you or anybody else have any other ideas in this sense? And yeah, I think just to motivate it, to me, this seems like the most pressing issue, and also the one that we can most easily tackle in the present, as opposed to a lot of these other things, which I think are more far off in the future. So,
yeah. So if somebody else wants to say something, you can, or otherwise I will give my opinion.
You go ahead.
Okay.
Just
so,
oh, sorry.
No, sorry, go ahead.
I just the question of Clement reminded me of a documentary I saw, or a piece about Estonia, where they have a very interesting case of handling open data. and where people can see who accesses and why and stuff. I don't know the details about it, but I guess you can look it up, because I remember it was quite interesting and quite...
What's the name of the doc?
Sorry?
Do you know the name of the doc?
It is not, no, I don't. I just Googled, there's an open data portal of Estonia.
Ah, okay, cool.
Yeah.
I'll check.
Yeah,
Yeah,
no problem.
I find it super interesting from like a, like even healthcare, like your health data, your internet usage data, all of this stuff. If you could get access to it, you could do so much with it.
Yeah, I think so too, that this what you proposed is infrastructure of APIs that a company must have. Sounds interesting. I think there would also be the further question, or first maybe the question, if we start to open up these these collections of data, if there would have to be some fundamental restructuring. Now it is the case that every company collects whatever data they need or have. Maybe there would in the first place have to be some regulations, and then yeah, I think this this could definitely work, this API approach. What I thought about this first point about the data access control is that there also might be some cases where maybe this this might actually not be possible to give people access to their own data, so to say. I was just this just came to mind. So let's say, for example, the idea of this is to some part to give people insight about how the algorithm works and how it rates them. For example, one can imagine, for example, an algorithm that rates the probability of a person committing a crime. So there, I'm not sure how this would look like. I mean, this would of course have to be covered by regulations, but I think aside from these specifically company or service related data collection, there might be this other part, this whole other part of data collection that is maybe a whole different topic. So where I'm not sure if and how a user can have access to it, but there would still have to be some control.
Yeah, you make an interesting point that ultimately maybe like the raw data doesn't mean that much, but giving information about how like the actual output of the algorithms and kind of what we talked about in Lorenz Green's presentation about explaining, like, yeah, you were shown this recommendation for these different reasons and these ways in which we've classified your profile. Yeah, that's
exactly.
They're not disassociated. They're the understanding the algorithms and transparent algorithms are also part of this data privacy aspect.
Yeah, and another point is that the idea that they propose is also that users could have control over who can access their data. But there, I think a big problem is that often when somebody else requests data from you, there is a power imbalance. So, for example, if the company you want to work for requires you to give them some specific records or data, and you don't want to, but then you don't really have a choice, because if you don't lay open your data, then you won't get a job, for example, or this might be the case if you want to travel to some other country and so on. So there often could be a power imbalance between the person that requests the data from you and yourself, so that you don't really have a choice to not do this. So maybe yeah, some of you have some thoughts about this.
I was wondering, by the way, how would you fold the flag?
pull the plug. And
Yeah,
this
that's
is a
what you
good,
were mentioning, right? If
yeah.
everything else fails, pull the plug, and then still it should work. Well, okay. Tell me how this is going to work out.
Well, yeah. I'm not sure if this is a realistic demand, but of course, so I mentioned it because it was in the paper, not specifically because I thought it was a good idea. So, I mean, the more complex this system would get, the more difficult, of course, it would be to have this option to pull the plug. Maybe pulling the plug is the wrong expression, but there could definitely be the option to override control. Maybe not everywhere. Many parts, maybe processes would possibly have to, or would not be. It would not be possible to override these processes, but let's say the key access point, the key decision points, maybe could still have some the option for a human to manually override in that sense and make the decisions.
You also mentioned kind of algorithmic transparency,
Mm-hmm.
And I agree, transparency is very important. But then the question is, which city is actually a smart city, and who is engaged? I mean, what company is engaged with the city?
Mm-hmm.
Are cities now just business models of certain companies, or that's something that we should know. So, what's your hunch? How many smart cities do we have in Europe?
In Europe, I mean, depending on how you define now, or at which point a city becomes a smart city. I don't think we have any city that is what the authors propose in this paper as a smart city, but I think we have
Singapore, maybe.
Yeah, maybe Singapore. In Europe, I'm not sure, to be honest. Maybe like from what I read in this paper, maybe Madrid is the one that comes closest, but I'm not sure. So otherwise, I would say there is a huge amount of cities that incorporate many smart city aspects, or maybe it's more that not the cities themselves are smart, but like the companies and the population use technologies that kind of already make them smart in some ways, some parts, but it's not specifically the city that. Okay, yeah, I just read about this yeah, control of yeah, I'm replying to Javier, or I don't know, sorry if I pronounce your name wrong, in the chat. Fine. Okay. Yeah, I just read about this, that apparently Madrid has computational control or organization of waste collection, recycling, and so on. Maybe you know more about this.
Yeah, I mean, it's very controversial. I would say that, yeah, you are very right on the way of when do we consider that a city is smart. Mm-hmm. It will be the first question. Many cities actually, I would say Madrid for sure has this kind of systems, but many other cities have other systems operating in different aspects, managing other kind of systems. Most of them actually are not very controlled by the government itself, but actually basically the city or the government is selling itself to a high-tech company, like a tech company, like whether we can be talking about Google, but as well we can be talking about Cisco systems, or about IBM, or about Telefonica. Actually, all of those tech companies are branding. They have been branding for the last 10 years about smart city solutions. Actually, it became kind of hype, and as well kind of like meaningless term. kind of empty thing just for branding. And now they are trying to sell very particular and very, let's say, customized, precise solutions for cities. But in a very technical way. Then we should consider where are all those aspects about like citizen participation, or about like keeping all those systems and algorithm accountable by people, or even, as you were saying, like that's a very important thing. Like even most of the technical staff or many of the politicians, actually, they are not understanding what's going on many of those systems, just because at some point they are providing like a very neat dashboard, and most of the people are very happy with this kind of like systems. I would say that it's mostly branding, and many cities are branding themselves like a very smart, open, very smart cities, and with a lot of open data. But then when you start to scratch it and to dig in a bit deeper, you realize that it's basically branding. So I would be like very careful about, I think that it will be like a very interesting topic of research itself, like trying to understand in many different parameters how different cities are applying a smart city or like technologies. But I mean, you can like consider only like traffic management, transportation, transit, but as well you can consider like systems for citizen participation or others. So I think that cities can be smart in different aspects, in different ways, and probably each of them are talking about many kind of different things.
Yeah, here's just some additional information. I mean, who's ever heard that Apple was engaged in smart cities? Please raise your hand.
Yeah, I'm raising, hold on.
Because, you know, on the internet, you find almost nothing. I came across it just by coincidence. Then, who thinks Zurich is a smart city? And how many smart cities do we have actually in Europe? So I was just searching for it a little bit, you know, and here's some document from the EU, and it says, according to criteria from the European Parliament's in-house think tank, almost all cities in Nordic countries are smart cities. Most cities with populations over 100,000 in Italy, Austria, and the Netherlands are smart cities, as well as half of British, Spanish, and French cities. In comparison, Germany and Poland are behind, while the Eastern EU member states have the lowest number of smart cities. And then there's 240 European cities with populations over 100,000 are smart cities, and then they provide a map. You know, I was hoping to see the names of the 240 cities, and instead they provide a European map where they say, in this country we have between 1 and 3 smart cities, between 4 and 10 smart cities, between 11 and 30, or more than 31. And so they don't even say what are the smart cities, you know, zero transparency. And then I was wondering, is Zurich actually a smart city? And there's a recent Smart City Hub webpage, and it says people also ask, is Zurich a smart city? You know, and most people are not sure. And here it says Zurich has been named one of the world's smartest cities again this year. And Switzerland's largest city is ranked third according to the Smart City Index for 2020, behind Singapore and Helsinki. You know, isn't that a surprise that nobody is talking about it? So it seems like to be happening behind our backs in secret. And we don't even know the companies who are engaged in this, nor do we know the people who write the algorithms, control the software, decide the policies, or anybody to talk to if we think something is wrong or something should be fixed, or you know, there is a concern. So you know, isn't that amazing? Or You know, how do you see this?
I think that it's like what you're saying, but as well kind of like self-perpetuating and self-justifying by institutions like budgeting, like spending money on some stuff which is unclear, and they are just self-justifying that investment on technologies or like in projects in cities, even though most of them, even the European Union has no idea about what the cities are reporting, and they are just, okay, yeah, Spain is saying half of our cities are smart cities. Okay, we accept that because we are justifying that way the budget. So I think that it's part of what you are saying, not reporting properly and not disclosing what's going on. And the other way, on the other side as well, this kind of self-perpetuating self-justification of budgets.
I wonder what would happen if cities were just business models of companies, you know.
Oh, they are.
I mean, is that the future, and would you want this to happen? Anyway, our time is over, and I'd like to thank the two speakers of today and everyone who's participated in the discussion or has been interested very much for the contributions and participation. With this, I guess we have reached the end of the semester. It was really a pleasure to interact with all of you. I enjoyed this seminar, and I'd like to wish you all the best. Stay healthy, happy, have a nice break and good start into the new year. And maybe we're going to see each other in another course in the future. Bye-bye.
Thank
you.
you.
Bye.
Bye.
Thanks a lot. Bye, guys.